Hi, welcome to the Submer Experience 2024. I'm Gloria Fluchá. I'm the CMO at Submer, and I'm really happy to be here. We have a really packed agenda for this year. As you know, last year we couldn't do the last edition in 2023, so we have a lot of things that have been cooking, a lot of them that are cooking right now for this edition. And so before we jump into the agenda and all the specifics of the session, I want to explain the rules of the house. This is a live streaming event, as I mentioned, so expect some live bloopers or on-air technical mistakes, so bear with me. We're trying to make this the best experience possible for all the audience. Also, the questions in the chat, you can ask questions in the chat during the whole session. Of course, everything is live, so in YouTube you'll be able to post some comments, suggestions, ask questions along the way. In every session, there will be probably some questions specific for the sections. Do not wait till the end of it, because we will be choosing some of these questions and we'll be answering them live with the experts that we have speaking here today along the experience. Also, it's important to say that we will not be covering immersion cooling basics today. This is a special edition, so if you have any doubts or you are not sure yet how the technology or the basic of it works, our colleagues in the backstage will be posting now a link in the YouTube chat. And if you click on it, you'll see all the visuals, infographics, and all the help you need to have the context enough to understand immersion cooling, so we can go deeper and with more technical background in this specific section. Now, this being said, this is the agenda that we'll have today. I'm not going to enter specifically into who does what, because I will be introducing them when we go to each of these sections. But going real quick, we have a company retrospective at the beginning. We have a live demonstration of the SmartPod EVO, then a customer testimonial from our friends from Viridien, one of our customers, an ecosystem session, followed by an R&D content that will be showcasing a lot of interesting things too. Then we have the SmartPod EXO demonstration, one of our latest additions in our portfolio. We'll have then the TCO, the total cost of ownership, that will be also supported by a sustainability part. And we'll be closing with the Why Submer with some of my colleagues from the C-level. And then we'll have the Q&A. As I mentioned, all the speakers will be participating and will be receiving the questions from the chat and answering them live. So, without further ado, now is the time to jump into the company retrospective, together with Patrick Smets, our CEO, and Paul Valls, our founder and CFO. Welcome, gentlemen.
Thank you, Gloria.
How are you?
Very good, extremely excited, I must say, and congratulations for the new Submerian on the works.
Thank you.
I can feel the difference. It's the first time for Patrick, but we've done that a few times before. Nothing to do. You cannot see the behind the scenes, but I'm really, really excited because, totally different story.
This is done quite professional. I mean, people could not see it, but the amount of cameras and people walking around, it's quite impressive. And I guess this was a lot of preparation. So thanks for that, Gloria, and for your team.
Thank you.
Really
And
well
thank
done.
you all the team and everyone involved, because this has been a really nice but hard path to arrive here. So I hope you enjoy this. I know this year we don't have challenges. We had some last...
Thankfully. Last time was tough for me.
I know Patrick is saying thank God.
I'm okay with that.
But maybe for next one, we'll have some challenges. So if you have some suggestions, you can put them in the chat. And maybe for the next summer experience, we'll have a nice challenge also live. So tell me, what about the retrospective of the company? What happened during the past months, year?
So you will see it. We have plenty of things that happened in the last couple of years. So we won't be going over everything, but we will highlight a few topics. I think the first one, why not where we are, what we call the Immersion Experience Center. We've created this space to deep dive into immersion cooling so that we have this full experience with a journey where customers and partners can see the technology firsthand, really deep inside the tanks firsthand, touching the hardware, touching the different components, seeing how easy it is to operate these things. So we made a huge effort in the day-to-day operations. We will talk about that later. So we've expanded our Barcelona headquarters together with our US headquarters in the US, where we will have something similar very soon, and Patrick will elaborate. And then in Taiwan, where we have also this lab. So expanding this type of labs and so on. Another interesting topic is the R&D efforts. I'm very happy and proud of the team we have. We've developed, in this case, the forced convection heatsink together with the ecosystem of partners, but this is kind of the simplest implementation to be able to scale with you in the hardware densities that we see. So all these runway of densities and chips that are skyrocketing in heat, and above even with the new versions of it that you will see also today, above the 1,000 watts. So exciting types of developments here.
And if I'm not mistaken, this implementation can be already, implemented in the products today, and it will be
available. It's available, and this is actually connected to the subsequent point. So the ecosystem and IT partners that we have. You can see that we've now broadened all the partnerships so that we have plenty to pick and choose, so that we can really implement any kind of IT configuration and support it globally with warranties, et cetera, et cetera. So very excited to see how all this ecosystem is actually proactively working with us now.
Yeah, I think we have a special section just for that. Yeah.
And finally, from my side, also the product portfolio. Obviously, we will deep dive into these two new versions of the product, the SmartPod EVO and the SmartPod EXO. Very exciting. I won't explain more, so no spoilers here.
Yeah, really cool, both products. And the launch was also really interesting too. A lot of interest that both of them have been, they inspire a lot of attraction, I would say.
Indeed.
What else, Patrick? What can you tell us more about the company?
Yes, well, 250 megawatts. 250 megawatts of immersion cooling deployed last year. That's an impressive number. If you would look back a few years ago, then we were happy with 100 kilowatts. Hey, we sold the tank, then was 1 megawatt, then 10 megawatts. Now 250 megawatt deployed in 1 year. That's quite of a scaling in the last years, both in containerized solutions as indoor. And this is just the start. I mean, we do have now more than gigawatts in the pipeline. So this is really scaling massively, and you will see that on the slide with the next milestones. There is all about further scaling our company. Yeah? And I think the next important point to mention here on the slide, aside of some other ones, it's the North America scaling. Yeah? Mm-hmm. We are already today the global leader in immersion cooling, but we want to expand massively our footprint in the USA. This will be our biggest expansion we have ever done in Submer. And yes, Gloria, I know that giving birth is probably more challenging than that. So congrats with that, by the way.
Thank you.
But going back to the scaling in the USA, we are going to open up a new facility of more than 50,000 square feet in Houston, and so to host all our people there. But we're also going to expand our lab capacity. Today, we already have labs in the USA, but we are going to expand that. Yeah? We're also going to have a showroom, and aside of that, we're also going to increase and implement our manufacturing lines in the USA, so that we are able to produce at scale the products in the USA for the USA market. And aside of that, we're also going to scale people. So we're going to ramp up a lot of new technical people, service people in the USA to really, really cover that market properly. So I think that's a big milestone for our company.
Yeah, it is.
Indeed, and to support that, we can make it happen. I think it's the perfect timing. Today we announced, and it's basically on TechCrunch and different media outlets, our growth funding round, more than 50 million. So I would say, guys, if you can make a big applause. I would like to thank all these investors for trusting us and welcoming M&G Catalyst, a more than 300 billion asset under management fund that can support us for the upcoming exciting future so that we can grow with you as customers and partners. And also thank you to all these other investors that are continuously backing us in the subsequent round. So they are happy with our progress and they do follow on investments. And all of them are impact investors, so really aligned with our core values. So yeah, thank you very much.
Thank you. I think that was a really packed retrospective on everything that happened. And a lot of things, more things happen, of course. But
Indeed,
if we
indeed.
have to choose, I think we did great choosing the few highlights that I think
Correct,
are
correct.
super important. And again, this is an exciting day because of the round two. So thank you very much for this section. Now we're going to be jumping into the SmartPod EVO demonstration. And I'm going to be introducing Danny Pratt, our product director, and Tobias Quaranta, who is our senior solutions architect. So back to you guys.
Hi, everyone. We are glad to show you our SmartPod EVO, which is the evolution of our SmartPod 4 series after 5 years of market and real customer feedback. Thanks to all this feedback, we have evolved our product to a ready for real operation one. With this compact solution, you can find the easiest path to immersion. And now, Tobias, can you explain us something about the efficiency of the EVO?
Yeah, I mean, it's an extremely compact unit. It's 41 RU. The nice part here is in 41 RU, which is a typical rack size, we can actually get 140 kVA. So that's quite a big density. For the 140 kVA, we could also run, if we wanted, in 70 kVA in high availability, because each one of these CDUs has 2 pumps in it, and one can take over for the other. At the same time, if you noticed, they're running right now, and it's extremely quiet. So those that are used to working inside a data center are going to understand that it's much more quiet to work with overall. Very efficient and compact unit. Back to you, Danny. Sorry.
Thanks, Tobias. So other key features are related with the easy to deploy. So with this compact solution, we have integrated CDUs. What you can see is a 920 tank with dual CDUs. So we have one CDU, another one. You can also deploy single CDU and upgrade to dual at any time when you need more power. You also have available half tank, which is the perfect fit for complex layout to take advantage of every square meter of your data center. All of this is with a fast plug-and-play solution, so we need power supply for the control box, and we need water loop for the CDUs, and that's all. On the other side, we have the fully revamped dry zones. They are bigger, they are modular, so now we can fit network or power, whatever we want in the front dry zone or in the rear dry zone, so we can adapt to any IT architecture, so it's really flexible. From the user point of view, we also have a lighter top lid. We have aluminum front doors, so this is for an easier operation. We have this nice handle, so it's really easy to access the top lid. And by the way, you can see how soft it works. Other topics are related with the maintenance, which is easier than ever. So now we have the control box, which can be attached to the tank, or it can be wall-mounted. In any case, you have a real easy access for any kind of maintenance task that you can need. And that said, Tobias, can you explain us a little bit about the IT operations?
Yeah, so because this is a 5th generation, we've gotten a lot of feedback from not only our customers, but from our different engineering samples, and we understand that, especially with the new high-powered servers, structured cabling is extremely important. So we take one of the doors off here so you can see areas for structured cabling. As you'll notice, everything's set up so it takes standard 19-inch accessories. And then we've got normal patch panels here, and you've got multiple options to put patch panels across the top. What's nice about having the patch panels here is that over on this side, on top, what I can do is just run immersion-ready cables on the wet side and regular cables on the other side. So, and the fluid itself, as you notice, all of the servers are fully immersed. And we've got fingers on both sides for additional routing. You can put PDUs in the back. We've got 19 and 21-inch sizes, and we can do OCP with a bus bar. Which is nice because then I could get rid of all the PDUs and I just use a power shelf. At the same time, a lot of people ask, well, how about, getting access to a server? They can slide right out. You take one of the network cables out. This one is powered up and it's still fine. I can just pull it out and service it. And yeah, don't worry about the coolant. It is a dielectric fluid. It lasts 15 years. It's biodegradable. It's non-toxic. It's food grade. Pretty easy to work with.
Now, Tobias, I guess we have some use cases we can explain.
Yeah, so this is my favorite part because this is what customers are asking about. So right now we're looking at, let's say, a high-performance compute cluster. So how do I get a high-performance compute cluster today versus what I should be doing, and what's my square footage and what I'm working with? So I've got 3,800 CPUs. I can take 16 of these pods, right, and get 3,800 CPUs. That is huge. I'm working with only 1,400 square feet. So if you think about data center sizes and the halls that you have to work with, getting that many CPUs into a very dense area is just fantastic for the way you're going to make use and the efficiency of that area. At the same time, I'm only working with water temperature of 31 degrees Celsius, still 88 degrees Fahrenheit. It is fairly warm, and I'm running an IT load of 1.65 megawatts. So just with those numbers, thinking 1.65 megawatts in 1,400 square feet, running 3,800 CPUs, that's what people are asking me about today. The other option that I hear quite a bit is our use case scenario 2. And in that, it's the AI cluster. So I want to deploy 2,000 GPUs, NVIDIA H100s. Again, I'm working with the same 16 pods, the same 1,400 square feet. I'm using the 30-degree temperature for Celsius, and I'm still doing a 1.25 megawatt load. That is extremely dense. The amount of normal cabinets it would take, or even direct-to-chip cabinets it would take, would be much larger than that in itself. So, and enough of me talking about what customers are asking for. Why don't we hear from one of our customers? So next we're going to hear from Scott Crowley from Viridien, talk about one of the projects that he's doing with us.
Hi, my name is Scott Cowley, and I'm the Technical Project Manager at Viridien. We use high-performance computing on an industrial scale to run complex algorithms at volume for our clients. We take an end-to-end approach, optimization from the infrastructure to the code, and we are committed to delivering innovative and efficient solutions to push the boundaries of technology. Today, I will talk about how immersion cooling is helping Viridien to improve the efficiency and optimize our data center performance. We do this by incorporating these advanced cooling technologies along with our cutting-edge infrastructure. Our aim is to stay ahead of the industry trends, ensuring the best service for our clients. So the first question is why immersion cooling instead of the more traditional methods? Air cooling, for example, failed to meet our efficiency needs as a company. Why did we pick immersion cooling? A couple of benefits include more efficient with lower energy consumption. It's simple with minimal complexity. Traditional systems require massive airflow, space, and maintenance. And immersion cooling is perfect for our high-density environments, focused on energy efficiency. For us, immersion cooling has been a game changer for our operations, largely due to that simplicity. The installation is smooth and easy to maintain. Additional advantages includes no extensive wiring or fans, and a really important one is noise pollution, much reduced. Everything remains neat, practical, and cool. It's easy as immersing the servers in the fluid and then letting the system handle all of that cooling for us. The impact from this immersion cooling, the energy consumption has been reduced year on year. There's fewer points of failure, the lower maintenance costs, and higher processing loads, which is really important. Being able to maximize that server density without overheating or having any performance issues is a key part for us. And we consider it a massive step forward compared to those traditional cooling methods, which allows us to scale and deliver more to our clients. So just to summarize our experience with immersion cooling, it's not only optimized our operations, but it's also reinforced our commitment to innovation. It's delivering in terms of performance, cost saving, and sustainability. And as a company, we highly recommend this technology to anyone who's looking to improve their data center efficiency.
So for our next section, which is the ecosystem, I'm welcoming Daniel Pope, our founder and CTO, and Cristina Medina, our partnership marketing manager. welcome to stage.
Hi, Gloria. It's great to be back at the Submer Experience. I'm going to miss the fact that we don't have a challenge this time. A lot of people have asked me during the year if we're going to get into a tank again and have a swim. But I guess we'll have to get very creative for the next one.
Yeah, that should be a cue for everyone live. If you want to make your suggestions, then you can see that Danny is eager to do crazy things. So, Christina, what about you? This is your first Submer experience. How is everything?
I'm really thankful that we're not doing any wild things. But really grateful to be here with you guys today.
Perfect. So, what has been cooking? What has been cooking in the ecosystem paradise?
So, Gloria, this year the ecosystem team has been working really hard to expand our validated catalog. And when I mean by catalog, I'm meaning all the server vendors, the accessories, the fluid options that we offer our end customers when they are shifting to this technology. What we are looking for with this broader catalog is to make our end users to speed up and make it easier for them to choose what's the best combinations for their full solution. This expansion that we're working on has helped us to include new server vendors in the offering, helping us to offer 3 types of servers. So now we are offering immersion-born servers, retrofitted servers, and then immersion-ready servers per project. So there are certain brands that are willing to give guarantees depending on the size and type of project. As we could see, we have well-known brands. So this will offer anyone or customers that are considering the technology to shift and to trust the hardware that they're choosing. And as we see that our pods contain a really powerful technology and the servers create all this high performance computing that we're looking for, the fluid plays a huge role in making sure that the well-being of the hardware is ensured and is also to dissipate all the heat that all these chips are creating. And as we can see in the slide, we're really happy to see that our fluid offering has expanded in a way that, again, we are looking for all our customers to choose the solution that will fit their needs globally and with the characteristics that they are looking for. And normally we see immersion as the pod, the servers, and the fluid. And sometimes we forget the components and accessories that also tie it all up together. And when we talk about these components, we mean by cabling, switches, bus bars, and we can see now in screens all the validated trans that we are working closely. And from this validation process involve our labs, but also our R&D projects. So I would pass the words to Danny because R&D is in our core and all our partners and the ecosystem brands are part of it, are making us go further in the technology.
Thanks, Christina. Yeah, a good example of how all this ecosystem comes together and collaborates together is obviously OCP, the Open Compute Foundation. It's an environment where there are hundreds of work streams, I think, at this point, even tens just on immersion specifically. And Submer is a very active partner since 2018 in the OCP community to try and accelerate, obviously, not just the adoption of immersion cooling from a supplier and vendor perspective, but also from the customer side, making sure that all those standards are available for people to leverage the technology in a simpler way and in a safer way. And so the OCP community, we're going to be there in a few days at the OCP Global Summit, and I definitely invite everyone to come and see us at the booth. But it wouldn't be possible to accelerate all this ecosystem without the massive investment that we have in R&D across our lab infrastructure. And those labs are placed strategically in the Bay Area to collaborate with, obviously, the suppliers and partners of the IT scene in the US. On the very other side of the planet, we have a lab in Taiwan, where we are working very closely with the APAC ecosystem and accelerating the relationships there. And then obviously in our Houston and Barcelona headquarters, we have thermal engineering, chemical engineering, and testing facilities to again accelerate the validation of this hardware and make it easier for the IT manufacturers to go on this journey of immersion with solid data backed with tens and hundreds of times that we've run systems in immersion, just make that a much more comfortable journey for everyone.
That's a great story, no? How the combination of a lot of key stakeholders in the market, we create the ecosystem, all these memberships, collaborations like OCP and others. And talking about R&D, thank you both, Cristina and Dani. I think now is the time to take a look to our R&D section. And for that, and before jumping with Dani again into the R&D section, I think we can hear from, there's personal experience, professional experience from one of our key partners, Intel. How was the latest project that we have done together with them? So.
Hi, I'm Mark McDonald, Principal Engineer in Intel's Data Center and AI Group. There's a lot of excitement these days about computing and AI, but less focus is being turned towards the amount of power these systems are consuming. In Virginia, home to Data Center Alley, roughly 25% of all the electricity produced in the state is going to data centers. And there's recent news that Microsoft is partnering to restart 3 Mile Island in order to power its data center endeavors. The EU is on the forefront of trying to use this energy more efficiently. Germany recently regulated that any new data center built 2026 or later must do some form of waste heat reuse. But waste heat reuse is difficult and can be expensive, partially because of siting and proximity challenges, but also because the quality of the waste heat or temperature of that stream is not that high, and it's difficult to find good uses for it. Intel cares deeply about these challenges and is working hard to optimize the performance per watt of our entire product line. So I was excited when Mark Miyoshi came to me 9 months ago with a collaboration proposal to try to make heat reuse easier. Together, Intel and Submer have demonstrated in a prototype system 500-watt Birchstream CPUs running on a server in an immersion bath at above 60 degrees Celsius. One of the key elements that made this possible was that we leveraged Intel's targeted flow cooling technology, which very efficiently cools the CPUs. At this bath temperature, the waste heat produced is directly compatible with 4th generation district heating without the use of supplementary heat pumps. Or, if your siting does not allow for heat reuse, at the very least you can use dry cooling regardless of what climate zone you're in, and reap the benefits of the lowest possible PUE and OPEX of any scalable technology. There's still lots of work to be done, especially around long-term material compatibility and reliability for this sort of high-temperature system. But I firmly believe that technologies like these will pave the path to a greener future for computing and AI. Thank you.
Okay, thank you very much, Mark. Appreciate the collaboration, and I'm going to show a little bit some of those toys. So basically what we have is a roadmap to sustain the technological runway that is coming to market, right? And everything was kind of nice and fun with 200 and 300 watt TDP chips, but we've gone to now 1,000 watts and beyond, right? And so Submer has been challenged by the fact that there was no solid roadmap to how to cover that. And what I'm going to walk you through is the different solutions that accelerate fluid and allow us to go from a natural convection environment to an accelerated flow type of environment. And that has a humongous benefit from many different aspects. In the case of forced convection heatsink, which I can show here and that we released last year at OCP, what we have is a traditional heatsink enclosed by a case, and the fluid is accelerated with these propellers. By doing that, we're able to cool chips up to 1,000 watts, and we proved that and showed it last year at OCP. And this is already being productized and built into different SKU solutions from different server vendors. So it's very exciting that that innovation has led to already real-life implementations, and we are deploying them in production as we speak. You can deploy this in any one of our tanks because it's tank agnostic. When it comes to the next level, and what AI has really brought to the table, is when we have to look at how do we cool beyond the 1,000-watt chips, right? And that is going to be done through a technique called the targeted flow. And targeted flow is basically injecting pressurized fluid into a server, into immersion cold plates, as can be seen here. So this is a very basic implementation and very early stage design of immersion cold plates. But as you can see here, we're injecting the fluid into the cold plate at the bottom and accelerating it through pressure, of course, so that it comes out. There's no return. It just goes out into the tank, and the tank will continue to take that heat through the CDU and heat exchanger, and obviously remove that heat, right? The beauty of it is that we just have one supply, and this supply needs to be connected to a pressurized manifold, which I will show in a couple of minutes. And with that, well, I also want to share that we will be showing a live demo of targeted flow at the OCP Global Summit in a couple of weeks. And in that demo, we will be showing a next generation cold plate solution for NVIDIA super chips. So we will be showing a small demo rig with a Supermicro system that includes 2 super chips. So a 2,000-watt server, 2 nodes in a single U, cooled by targeted flow. And we're very excited to obviously showcase that together with our partners that you can see on the slide. And now what I'll do is I'll run over to the tank to show you what that looks like from a tank perspective. So a sneak peek at the EXO, we still haven't spoken about it, and it needs to, we'll have time to go through it in detail now with my colleagues, but I'm just gonna focus and zoom in on the implementation of targeted flow at the tank level. At the tank level, the only thing that we need is a pressurized manifold, and that pressurized manifold is fed by the same CDU that provides fluid to the tank and to the bottom of the tank, and then naturally raises that fluid through the tank. So the way this works is that the CDU controls the amount and type of pressure that gets delivered to the manifold based on the type of systems that we deploy in the tank. And when we deploy that server that I was showing over there into the tank, all we need to do is connect it into one of these quick disconnects that can be seen here. So this part of the quick disconnect would include a hose into the server, as shown before at the table, and then you would connect that hose to the pressurized manifold, and you would be receiving pressurized fluid to the tank. So this is a solution that we've already incorporated into our product, and it enables what Mark was talking about, the possibility of pushing things to high temperature immersion. And high temperature immersion is really about if you have a system and a chip that is able to operate at high fluid temperatures, and they exist today, as seen together with Mark and the Intel CPUs, you are able to inject pressurized fluid at a 60 C supply. And that has a humongous benefit and impact. Not does it only work from a technology perspective with no throttling and with better performance for the server, as long, again, as the chips support it, but also there's a great opportunity for heat reuse, heat capture and heat reuse, because if you're injecting and supplying 60 C, the return is going to be much higher than that. But the opportunity for dry cooling and efficiency at the mechanical plant level, which we'll be hearing a little bit about in our TCO section, is extremely compelling and exciting. And so that's one of the key innovations that we think customers will be able to play with to decide if they want to optimize for performance, lower the fluid temperature, increase the pressure and liters per minute of flow that come out of the manifolds to obtain better performance or potentially even overclocking of CPUs, or if the goal is waterless, dry cooling, efficiency at an infrastructure level, warmer fluid temperatures, and better performance of the overall infrastructure. And with that, I'll hand it over to my colleagues Asanka and Albert to walk you through our new product, the SmartPod EXO.
Thanks, Danny. So the EXO is Submer's latest data center grade product which we have in the market. It's obviously a result of a lot of hard work from the R&D teams and the product teams to come up with this design which helps our customers to grow in scale, right? So with that in mind, Albert, can you walk the live audience through the two different variations we have on the product?
Sure, Asanka. So basically, the SmartPod EXO, it's getting all the knowledge we have learned in the past with our customers and experience with the SmartPod EVO, but also understanding what are the roadmaps of the IT that it's coming in the future, and we have already now available. And based on that, we decided that the SmartPod EXO would be able to be deployed in two different configurations. One is the unit-tank configuration, and the second one is the twin-tank configuration. What we have here today is the unit-tank one, and the goals of those two different configurations is to tackle two different type of approaches. The unit-tank, that is what we have here, is about extreme performance. It's about really having the capabilities to bring this solution up to more than 350 kilowatts if needed, which today maybe it's not needed, but what it's going to give us is a future-proof platform for what's coming from the IT side in the next 5-6 years. At the same time, there are a lot of deployments that maybe they are not looking for this type of high performance of 300s, and they are looking more for a high availability and being able to offer services that are based on SLAs that are very high, and that's the twin tank option. The twin tank option is about having two tanks and two CDUs combined as a single system. And the benefit here is that we can go to more than 250, 270 kilowatts, so it's still future-proof, but making sure that we have a high availability of 5 nines, and we have concurrent maintainability, which brings us to the point that that system that has two tanks and two CDUs can get one CDU out because maintenance or because we have to change it, and we will keep both tanks up and running, no changes on the performance, and this will allow us to offer Tier 3 deployments if needed, because of the high availability and concurrent maintainability.
Yep, thanks, Albert. With that in mind, can you also walk us through the key features of the EXO, as well as the benefits when it comes to ease of operation and maintenance point of view as well?
Sure. Another thing that we have done with all the R&D in the EXO the last years is not only focusing on how efficient is the EXO, but also thinking at scale. And at scale, the EXO will be in locations where the facility water system is a key player also in the consumption of the energy, right? And here is where we have done several specific developments in the CDU that allows us to simplify the water facility in the location that we are deploying the EXO, and also optimizing the usage of that facility, which means that it's not only that we develop a product that is highly efficient, is that we make the facility water system that it's not ours more efficient. So the whole solution is to optimize the operation cost. So if we move to the IT side, and now we will see inside of the tank, what we have done is that, as we have done with the EVO, we have the capability to do cable management properly in order to be sure that we can guarantee the SLAs when we have to change servers, when we have to do changes on the optics or on the cables. And that's because, as Danny Pope already explained, this is a design that is focused on the high-performance environment, right? And in those high-performance environments that most of the times will be for AI, we will have a lot of GPUs. So today we have here 150 GPUs. In the near future, we'll have 200 GPUs, and where we can reach with GPUs is not only something that the server market will define. And then it's what can you do about cable management? Because the SLA of this tank up and running is about how fast can you change the server, how fast can you change the NIC. And here is where, if we can see on the back, when we have the manifold, it's also, you will see that there's a lot of 19-inch standard supports, which will allow us to put standard 19-inch cable management solutions like patch panels. This means that we can have more than 500, 600 network connections using patch panels in a structured way to make sure that the SLAs that any customer wants to offer on top of this tank is compliant with whatever the service of the customers are needed. So what I would say here is that we have to do two different angles. We have optimized the efficiency of the tank to tackle high performance environments. We have optimized the needs of the water facility system to optimize also that part. And then we are focusing on the SLAs for the IT operations so the customers can guarantee the SLAs properly.
Right. Thanks, Albert. I'm also aware of the interests the industry has in terms of how NVIDIA high-density chips behave in an immersion cooling space. So can you run us through a scenario where in a high availability application, the NVIDIA H200's chips, how they behave in a scenario in that situation?
Sure. So this is a typical project design that we have today. It's about how about deploying at-scale GPUs. And one of the scenarios that I have prepared is about an NVIDIA H200 scenarios with more than 2,000 GPUs, in this case 2,400. And we can see is that using 154 square meters of space and waters at 27 Celsius, we can reach loads of 2 megawatts. And this is very important. This is based on the H200, right? And also the density that today the server vendors can put inside of this tank. But this is something that is only getting bigger and bigger and bigger because the next chip is not the H200, it's the B200 with more TDP. And also the server vendors are optimizing these designs, which means that with the same space, we will be keeping up the pace, and without changing the infrastructure of the tank, you will be able to upgrade, and increase the total density that you can have within these AI clusters scenarios.
Yep. Thanks, Albert. Really interesting scenario indeed. Now, can you also run us through another scenario where, because free cooling is a huge advantage when it comes to the operation of EXO, right? So in a free cooling scenario where the system operates at a high temperature, can you explain the live audience on how that scenario would work?
Sure, and here I will differentiate two different things. One is what already Danny Pope advanced about the manifold and how we do the direct connection of the flow. But even without this technology, today the EXO, the scenario that we are showing today, is a scenario that we have designed with ambient temperatures of 45 Celsius, so anywhere in the world that you have an ambient temperature of 45 Celsius as peak temperatures, with the layout that we had before, the same number of tanks, 154 square meters, we are able to provide 1 megawatt of IT load without yet using this technology. Yeah? The moment that we use this technology, we can scale up that load, but without this technology, so with servers that are available today, we could have this type of deployments. And the key thing here is that it's free cooling. So the operational cost of electricity or water, if in that case, for the next 5 to 10 years, is going to be minimized dramatically because of that dry cooling capability. That's one of the key things that we can do with these EXO designs.
Perfect. Thanks, Albert. The EXO is definitely, I would say, a game changer for the next few years as well.
It is.
So with that, we'll move on to a video about the EXO for the audience.
Sure.
Introducing the SmartPod EXO, our immersion cooling pod that tackles the data center challenges of today head-on. Setting new standards in performance, the SmartPod EXO ensures your data center is future-proof and climate resilient. How? Let's dive into the benefits. Dissipate up to 361 kilowatts. Opt for the twin tank to experience 5 nines availability with concurrent maintainability. Meet your sustainability goals and future-proof your facilities. The SmartPod EXO is heat reuse and dry cooling optimized, offering you the chance to eradicate direct water usage entirely. Operations with the SmartPod EXO couldn't be smoother. Modular cable management simplifies your setup. Seamlessly add standard 19-inch patch panels and accessories. With PDUs located in the dry zone, maintenance is fast and simple. It's time to level up your data center with our liquid cooling technology like no other. The SmartPod EXO, enduring performance to rely on. Submer, data centers that make sense.
So thank you very much for this SmartPod EXO demonstration. It was really interesting. Now, for this section, total cost of ownership and sustainability, it's a really special one. So we're gonna be, I'm gonna be handling the torch to David Montes, who is our product marketing manager, and is gonna be the one hosting this session in the sofa stage. So back to you, David.
Thank you, Gloria. Thank you, everyone. It's very exciting to be here talking about, I would say, one of the most trending topics nowadays, right, in the data center industry, so TCO models and sustainability. But obviously, I am not going to cover this topic by myself. And for that, today I've got with me Patrick Schettini from Hypertech, VP of Global Sales and Sustainability Evangelist. Welcome, Patrick.
Thank you.
Also, Richard Voss, a data center MEP consultant with a lot of experience from Derns. Thank you, Richard, for being here. And also Natalie, our own head of ESG and sustainability.
Thanks, David.
Thank you, Natalie, for being here. Okay, and let's jump straight into it. So the main idea about the model that we are going to show you is that the very first one, and it's very important that the model, so the data that you are going to see, this has been created by Derns and with the support from Hypertech, ourselves, Submer, and themselves, their own data library. And well, Richard, who is better than you to explain what this is about?
Yeah, to help Submer on the solution and making clear what are the benefits of this solution, we built a TCO model. A TCO model is basically to calculate the capital investment from the tank itself up to the complete impact on the mechanical infrastructure, the electrical infrastructure, the building, the energy consumption, the water consumption, basically up to the boundary of the building and beyond. So also what will be the connectivity to the outside world, what will be the water requirements, what will be the potential energy reuse. So to develop that concept, basically we said, okay, we need to have some baseline to compare various cooling technologies and the benefits against each other. So what we did is we made a modular design for this cooling concept, went up to level LOD 300, so basically going up to isolating valves and other required accessories depending on the tier level. And from that perspective, using our international standards, for instance, for the definition of the calculation of the power used effectiveness, we try to assess this system compared to other systems with some surprisingly effects. So hopefully we can deep dive into those.
Of course. So let's start by defining, right? So what the model that we are going to see today is about. So so first of all, when you do a TCO, you have to define the apple, right? So because we want to do an apples to apples comparison, a like for like comparison. So for today's occasion, the Apple is going to be 12,000 GPU-based nodes, right? Later on, we will see what a node is. As for the cooling technologies, we will compare traditional air, DLC, direct-to-chip, and Submer immersion products. And as for the scope, so we will cover from the chip all the way up to the infrastructure. Okay, and now let's start with the definitions of the various items that we are going to cover. So the first one, GPU-based node. So what is this? So in order to make, again, so the apple, right, in order to define the apple, so what we are going to have is the same, let's say, compute power for the nodes that are going to be used on each of the cooling technologies, right? So as you can see the table, the compute power is the same. So that's the one part, right? And then on the right-hand side of the picture, you can see, so for example, in this case, a representation of an immersion node, or based on an immersion node, where you can see there are 3 GPUs in blue color, and you can see the section on the left where it says node. So what we mean by this is that when we say GPU node, is the GPU itself, obviously, plus all the related components, the proportional part of related components. And this is true for the costs of those components and also for the total consumed power. As you can see, they are different depending on the technology, right, Patrick?
You're absolutely right. I think this is the first slide who show right at the get-go the difference between the whole technology. As you can see, in terms of compute power, this 900 watts, there is nothing added at the cooling level for immersion cooling.
That's completely right. And now, so let's continue going up. So we started with the server. Now let's see what rack or pod is in this scenario. Can you help with this one, Richard?
Yes. Of course, to create a uniform design, we basically made some starting points. For the traditional air concept, we make use of a 12 kilowatt rack, which is, I think, a state-of-the-art data center design. For the DLC, we assumed a 75 kilowatt per rack. And for the liquid immersion, we assumed a 35 kilowatt capacity per pod, being the EXO. The monoblock, the Unipack. Traditional air, we assumed it will be an air-cooled concept. Air-cooled concept in this case will be with the use of CRA units or fan wall units. The direct-to-chip cooling, there will still be some heat dissipation into the room. The cold plates connected onto the chips will be capable of cooling approximately 70% of the heat being generated of the total IT equipment. So the waste heat will be either cooled by CRA units, as it also creates a relatively high amount of heat dissipation. As the liquid immersion tank is an insulated tank, there is slightly heat dissipation into the room, also from the system, from the piping serving the liquid immersion pods. So for that scenario, we assume to be crack units, so the DX systems. So for the environmental conditions, we allowed with the ASHRAE TC 9.9 window, we go for relatively conservative 24 degrees Celsius, but to compare apples to apples, we use this temperature regime throughout all concepts, although there are multiple discussions on direct liquid chip or liquid immersion going to higher regimes, but to keep it a plain ball field. And for the cooling generation, basically we went for optionals being a hybrid dry cooler, so making use of an adiabatic system, and also making use of dry cooler. And as a state-of-the-art data center, we will do everything that cannot be covered by standby chillers. So that will compensate the waste heat that is not covered by the other cooling technologies.
Excellent. So we've got the Apple here again for a fair comparison. And now I would like to explain something related to the costs and how they have been used, right? So as you can see here, you see a representation of a node, right? That could be the white box. You can see for every white box you've got like the compute, right, on the left-hand side, and also the cooling hardware, right, represented by a fan. The thing here is that, in order to make a fair comparison, right, and for the Apple to be really an Apple, the cost of the cooling hardware within the servers is being considered as cooling cost within the infrastructure. So what you can see there with the gray box. And so Patrick, I guess you would like to say something about this one?
Yes, again, here you can see that immersion cooling, and that's the work we have done with Submer, for example, is to try to remove as many components as possible. The first one to go is the fan, and is extremely beneficial for a CapEx or OpEx, and as we will see later during the conversation, is also very beneficial on the sustainability aspect.
Absolutely, absolutely. Thank you, Patrick. So now let's see what the TCO use case is about. As we discussed, 12,000 GPU-based nodes. We have selected, let's say, a challenging location to perform this model. So this is Phoenix, Arizona. Availability, it's going to be tier 3, equivalent to tier 3. As for the IT capacity, it's going to be equivalent to a 12 megawatt air-cooled data center, just for reference, right? The goal that we have pursued here is to design for the best possible PUE, well, design PUE actually, because this is just an exercise and this data center hasn't been built just yet. you've got the period that we have calculated, the operational expenses, 15 years, plus the inflation rate, and also we have considered a 90 hardware refresh cycle of 5 years. And with this, Richard, I would like you to please let us know what the main findings are.
Yeah, we did an assessment on Arizona, really challenging ambient conditions, noticeable on its really warm peak summer conditions. So what we did assess basically for key performance indicators. We did more than this. It's also operational and capital expenses. But the key drivers in this study were the peak PUE, so the peak power ratio, resulting in how big must my power supply be to fulfill the requirements of the data center. We did an annual PUE, basically based on hourly weather data of the weather station in Phoenix, Arizona. And we also did an assessment on the water usage effectiveness. And what we do see is we see big differences in the three of us. And I can explain you what is the driving factor behind this. What we see in the comparison between our concepts is that due to the fact that direct liquid chip still got some heat dissipation into the room, we now went for a 30% heat dissipation in the room, either cooled by CRA units or by rear door coolers. There is still a requirement for a low chilled water regime to serve those equipment to keep the room conditioned. What will be the result of that one is that adiabatic hybrid dry coolers are not able to provide full heat load or cover the full heat load, and chillers need to jump in, standby chillers, and they need to be size bigger compared to the Submer immersion mono tank, unitank. We see that effect even more on the traditional air cooling. So what you really see is like going steps from a high peak to a low peak, that the DLC falls more or less in between the traditional and a Submer immersion cooling solution. You also will see that same scenario within your water usage effectiveness. And water usage effectiveness is in this case also affected by the peak saving by the room coolers. And that the room coolers have a lower regime, so the adiabatic humidifiers should be switched on earlier. A second one that we also investigate, of course, is the impact on cost, the cost-driven factor. There is where we categorize this in multiple subcategories. First of all, the electrical power consumption. In the electrical power consumption, we see throughout the year there are some benefits to liquid immersion, especially if you compare it to traditional air concepts. So we see already a saving, if you take it in consideration, a 15-year period of multiple millions. Same accounts for the water consumption. There is also potential saving not only on the commercials, but also on the footprint it has on its environment. And we also see some huge benefits in the maintenance, basically resulting in over 46 million saving in the lifetime of 15 years. So I want to provide a little bit more guidance on the figures that made the operational cost. If I only compare the direct liquid chip to the Submer cooling solution, you see the Submer is slightly bigger, and that's related to, of course, the active components that will be installed on the Submer tank. You have the pumps, you have the plate heat exchangers, you also have some valve items, so there is a slight increase in your operational cost. But you see that's almost compensated by the additional energy or cost that will be made for the maintenance of the CRA units as well as the chillers. There's also a significant difference in the notes. Patrick, maybe you can jump in on this one?
Yes, I think, thank you. You can see here at the cooling of the hardware, and when you talk about maintenance, all the time we spend in R&D was to develop a product who's as easy to install and especially to maintain. We already know that immersion has a much lower failure rate than any other technology. And on top of that, we made it as simple as possible and as almost a zero cost, as you can see, to maintain. So it's a kind of a double whammy, a double benefit all the way.
Yeah, you should also, if you go on, also savings in the water treatment maintenance, as there will be a lower frequency of usage of water. The water treatment needs to regenerate less, salt is less used. Also, there is a significant difference in the electrical infrastructure, and that's also again driven by the cooling required for the room conditioning. As these chillers need power, the electrical infrastructure serving that mechanical systems is bigger, and by that also requires more maintenance costs. And one thing that was a bit surprising to us also is that we also see there's less cost in the building if we compare direct liquid chip to the Submer cooling solution. Although densities of direct to chip might be higher from a rack perspective, a square meter perspective for direct to chip, we see that the serving system serving the direct to chip also of course requires space, and in the end result in a bigger footprint of the building. So overall you see a very attractive 55% reduction if you see it long term saving in your operational expenses. We also try to combine this one in the long-term graph. And we started zero. That was not by coincidence, but that was something that we also see during the case study, that the capital investment didn't change that much between the various concepts, but due to the time we were happy to explain that in more detail in further discussions. But you see that also in the long term, there are benefits going submerged, and that's in this case does take into account the operational expenses I just mentioned, and does not even take in consideration the heat recapture potentials of this cooling technology.
Thank you, Richard. Definitely, it's very interesting to see the benefits, right, that the immersion cooling can bring to the table, but it is not everything about figures and numbers, right? So there is more, and one of the important things is also sustainability factors. And Natalie, can you elaborate a little bit on that, please?
Yeah, thank you, David. I totally agree with you. It's great that the technology is economically interesting, but we shouldn't forget the impact. When we're looking, I'd like to zoom out, onto the globe and not just Phoenix. And if you go to next slide, we can see that from the IPCC, the forecast in temperature raise is massive. And you can see many regions all over the globe are going to be affected by over half of the year with 35 plus degrees, 95 Fahrenheit, to be dealing with that, which means that data centers are going to have to adapt to be able to run with very high temperature. And immersion cooling allows them to do that. When you're looking into the water stress, the same, like all the globe and many countries are affected by water stress. Water with cooling, we know, is important. You need direct water for the cooling systems, but also for the energy generation. And so water stress is a big issue, which immersion cooling helps resolve. And if you look into where data centers are concentrated, you can see that many of them have both the issue of high temperature and water scarcity in the next years coming up. And it's crucial for data center to adapt to the climate risks. So it's great to have financial advantages to move into a technology, but also to be able to be adapted to the future is key.
Thank you, Natalie. And in relation with this, this model that we have presented today, as we discussed at the beginning, we have the aim has been to design for the best possible PUE, right? But what would happen if we wanted to design for example, zero water consumption, right? What would be the things to be taken into account, Richard?
Yes, we integrated that technology into the model. So basically, by selecting various alternative solutions, the model automatically generates the outcomes. In this case, we compared the same apples to apples based on hybrid dry coolers as well as dry coolers. And what you see, and what of course makes sense, is that during peak ambient conditions, we require more chiller capacity. The chillers need to run at higher condenser temperature. So in the end, the chiller power consumption increases. That will have significant effect on the annual and peak power consumption for the traditional air, but will have less for the liquid immersion cooling solution. And that's related due to the relatively high temperatures of the concept. The impact is only noticeable mid-season during the summer of the year. And you see, again, due to this local room coolers for the heat dissipation of the direct-to-chip, that there's also an increase of annual power consumption if you eliminate the complete use of water. So it's basically a local alternative to select either going dry, having a higher power consumption, or still making use of adiabatic systems.
So I think this one is another slam dunk, in my opinion, right? When you look at best case scenario, best design based on PUE or best design based on PUE for 0 water consumption, you can see Submer is the flat-lighted one, is the most predictable, is where we need to go. I will be flabbergasted if someone chooses traditional air cooling when you look at this slide, because it's a catastrophe for the environment. And as you can see, the more you go to immersion, the better you are.
Absolutely, and I love to hear that, Patrick. And well, just now the conclusions. So 3 of them. The first one is about the TCO itself, right? So savings with immersion start from day one, as you have seen. So yeah, this is what you can get. So the second one, Patrick, do you want to take this one?
So how do you improve your OPEX, right, year over year? I think the way immersion cooling and especially Submer and ourselves at Hypertech look at the problem is how can we develop for something who's going to last longer than it's supposed to be. And that's how you improve the operating expense, right? The entire OPEX is to think in advance. What do I need to do today to be more beneficial tomorrow?
Absolutely, today and tomorrow. And what about the sustainability aspect, Natalie?
Well, as we mentioned, immersion cooling helped data center reduce massively their environmental footprint, and above all, it helps them adapt to the future climatic conditions.
Absolutely. Thank you again, Richard, Natalie, and Patrick.
Thank you for having us.
And over to you, Gloria.
Well, for the Why Submer section, which is the next one, this section is going to be basically for each of us, the C-level team that it's together with me now. We're going to be having 1 minute of explaining the reason of why Submer, and not just why Submer, but why immersion cooling and not another technology, or why immersion cooling, and then why from all the immersion cooling solutions that there are in the market, why Submer and not others. And for that, we're going to be starting with Danny. So Danny, do you want to say your first why Submer?
Yeah, my vote is for TCO, as we've just seen. Look, we've deployed immersion in the crypto mining industry as well, apart from the data center industry, which is our core focus. And in that industry, immersion today is the de facto cooling standard for deploying infrastructure. And so why? Because the TCO model is extremely competitive versus all the other technologies that are available in the market, right? So when you bring that back into the data center industry and you look at what happens from the chip to the server, to the rack, to the data hall, to the infrastructure, mechanical cooling, water plant, et cetera, and so on, there are solid reasons and competitive data to defend that immersion has the most solid TCO from a cooling infrastructure perspective, and from a whole facility point of view. And so we believe that as the liquid cooling technology adoption accelerates, people will have the time to sit down and work out these TCO models and see and understand that immersion is there for the long run to future-proof the infrastructure.
Trusted partner. So I think it's also about being a reliable and trusted partner because nobody is buying immersion cooling for the next 2 years. You are doing an infrastructure investment for the next 15 years and longer. And so that means that you want to have a partner next to you that can support you over that time frame, that can provide the service, that has the know-how to improve the product, because the technology is still evolving. So, and we do believe that Submer is very well positioned to do so, because we are the global market leader in immersion cooling, and we are only focused on immersion cooling. So that means that all the R&D and the resources we have, we are putting into immersion cooling, and this all to improve our products in quality and reliability. So, yeah.
So another why is leading ESG and efficiency strategies. Submer not only means submerge, but also comes from the acronym. Our values are the acronym, and Submer starts with an S from sustainability. And one of the things that we see from the inside of the industry is that we are seeing more and more regulations coming. CO2 emissions, energy efficiency, circular economy, heat reuse, water consumption. It is expected that data centers will consume more water than even half of the UK in the next years with all this AI rush. And then we see also emissions going even above, or electrical consumption, even above of any European country. So all these things are getting more and more worse. And we have the right backing with impact investors that have the intersection between rapid growth and backing the company to support you, but also with these impact values that allow us to help you with the non-financial reporting, ESG, et cetera, et cetera.
And if I may add, at the end, when you go to production environments, people deploy data centers because of the services that they are going to offer, right? And nobody will offer a service that cannot guarantee with SLAs, and that's all linked to the predictable IT operation. So moving to an immersion data center at scale, it means that the people need to be able to predict how operations are going to be done properly to keep the SLAs. And here there are three pillars. One is products design thinking on this. We design all our products thinking at scale operations in the next 10 years. Two, having the right operation guidelines, and we have work on that. And three, having the right tools. And Submer is covering the three parts to make sure that any customer approaching us will have a journey together to deploy at production scales.
And last but not least, future-proof data centers, right? Which basically, I would say that it's a combination of almost all of them, the ones that were mentioned. And this is because when you deploy a data center together with us today, it will be ready for tomorrow. As you have seen in the whole session, we have all the building blocks for us to be packing or to be supporting you in every aspect of the data center, from the chip till the infrastructure, everything that goes into the tank, as Christine and Danny explained, like chip manufacturers, cabling, fluid, everything that goes in the tank, from the tank itself, the mechanics, the software, and then in the infrastructure level of the facility, working with MEPs, facilities, system integrators. So we have all these synchronized closed loop to give you the best service, and having these basically expertise on thermodynamics, R&D, chemicals, software, mechanical. So at the end of the day, if you really want to future-proof your data center, Submer is the best partner for it, is the best fit. And I'm going to close this section with this slide that for me it's really important, because basically it's what the iceberg represents is what normally people the perception that the society or the industry has about us, which is we're a tank or a vendor of cooling, no? A tank provider, but is actually just what you can see, but what you cannot see is all the reasons that we just explained today that combine make us the better investment for your facility, not just today, but also in the future. That being said, and before we jump into the Q&A, I want to mention a couple of things. There will be a link into the chat right now where you can click and you have access to the survey, so you can give us your feedback. And also you will have the option of register into a more deep dive session of the sessions that you have seen here. So if you like the EVO, the EXO, the TCO, ecosystem, you'll be able to choose that from there and have a follow-up with us in a more deeper level. That being said, let's jump into the Q&A. So I see that everybody's ready in the stage. So let me check how the questions that have been compiled from the chat. Okay. I think this one could be good for David because this is for the TCO. So David, someone is asking, this TCO model doesn't work for me. Is it possible to get a customized one?
Well, yes, that's a very good question. Yeah, obviously, even if we have selected a location that we think it is quite challenging and therefore it's quite representative, right, of the benefits of the immersion cooling technology, that case doesn't apply to everyone because, well, obviously the starting points and the goals we have seen, you know, the lowest possible PUE, zero water consumption. Well, there are many variables, right? So what I have to say, actually, is that we are more than happy and to entertain, you know, any request about doing TCO calculations and show the benefits of immersion cooling for the use cases of our customers. Yeah.
Yeah, just to add on it, basically the TCO model is built with a use data library, which we collected as a company over the years with several tender returns on projects. So what we already did incorporate in the model is the big library, where it basically selects equipment selection, but also the equipment performance selections, as well as a big data file collecting weather data from the X-ray fundamentals, so different tier levels. So basically we already incorporated multiple alternative technologies or alternative solutions to basically create a quick return on specific case scenarios.
Perfect. Thank you very much, both Richard and David. Now I'm going to be handing this to Albert. Is immersion suitable for general workloads too?
That's a very good question because we are talking about a lot of TDP chips that are very heat dissipating and powerful. But if we remember, the last scenario of the EXO was about free cooling. And that is where this type of workloads can benefit from this technology, because at the end, you still need to cool down those servers, right, and that IT. That kind of workloads can benefit from the technology, because at the end, what we will be able to do is optimize the whole cooling cost in the next 5 to 10 years of that general compute by using free cooling at the maximum capacity. And that's going to be key for being able to optimize workloads that are not going to be high TDP.
Okay, I think that summarizes the answer. Asanka, I don't know where Asanka is there. How can I test out immersion cooling?
So what I would suggest is, in that scenario, come and talk to us in terms of what application you plan to run in immersion cooling. And then we could work with our ecosystem partners and work out the best IT to work with you. And then I would suggest to run like a pilot project or a proof of concept. Then that's going to help your maintenance teams, operations teams to get more familiarized with the technology. And then I would say finally we could then help you to design in terms of how to integrate in immersion cooling to your existing infrastructure, so without changing too much, your current environment, to how to incorporate in immersion cooling.
Good. Tobias, this one is for you. Are you ready?
Yeah, I think so, if the mic's on.
What advice would you give to someone for retrofitting their air-cooled data center for liquid cooling?
Okay, so that one's kind of easy. First, give us a call. While I'm in Barcelona today, I'm normally in Northern Virginia, and we have teams in Asia Pac, Europe, and the United States. Second, as long as we've got access to a water loop, it's not going to be a problem. So we're going to come out, we're going to meet with your site, we're going to meet with your infrastructure guys. We'll take advantage of the cooling that you currently have today. For those that are currently have stranded power, and what I mean by that is they've got cooling, but they've got more power available than they have cooling for the data center, that's a perfect application for us to come in and take advantage of the excess power, and we'll work with your existing units, whether it's hybrid, whether it's a dry chiller, whichever units you currently have today. As long as I can get access to your water loop, we'll be fine.
Great. And I think this is going to be the last one because we don't have that much time. For Natalie, are there any advantages sustainability-wise aside from water and energy?
There's many advantages with immersion cooling. You can use it in brownfield, for example, so reducing your carbon footprint with the building itself. You don't have to build a new data center. You can just use existing premises to install immersion cooling. We mentioned about heat reuse also, about the servers. Immersion cooling ready servers have 25% less material than air cooling server or direct to chip. So many other advantages on the sustainability point of view than just energy and water.
Thank you very much. And I think that was all for today. So please answer our survey, and you have our contact email at the slide that will be showcased in a minute. Thank you very much for today, and thank you everyone that made this possible. Bye-bye.
Thank you.
Thank you. Bye.